G'day all, and welcome to another tute. It's been a long time since I did an assembly in C++ tute, but we're going to get stuck back into it. I've actually been working on this, amongst other things. Imogen is the name of it. It's my new image processing application. And this really comes about because of this tutorial series, so let me explain what we're doing. What I decided to do was tackle AVX in a completely different and much more practical way to the way that we have been tackling most of SSE in the previous assembly. What I decided to do was make an image editing application, or a image manipulation application, and it's called Imogen. So I first decided that this would be a really good way to introduce a lot of assembly concepts a long time ago, but now that we're at AVX, there's a bit of a problem. Almost every single image in the world is in 32 bits per pixel format. You might remember from our adjust brightness algorithms and tutes a long time ago that pixels from an image are stored in red, green, blue and alpha, and each of those components is 8 bits or a byte. This actually leads to a lot of artifacts when you're manipulating images. So if you really stretch the contrast, or you stretch a histogram out in a 32 bits per pixel image, you'll quickly find that individual pixels become really stark and visible, and it's not a very good artifact at all. But the other thing is that AVX actually doesn't have any integer processing ability at all at the moment. We are going to get AVX2 later on this year, 2013. And that's actually going to have integer abilities as well as floating point. But the AVX1 that we're stuck with at the moment is actually only floating point. So what I decided to do was make a 128 bits per pixel photo editor. And it's called Imogen, incidentally. 128 bits per pixel, as you can probably imagine, is much more information than 32 bits per pixel. And each of the components, red, green, blue, and alpha, is stored as a floating point value. So AVX and SSE, and if we end up looking at this in CUDA or OpenCL or something like that, we'll see that these hardwares that we've got are extraordinarily good at processing floating point data. Anyway, that's why I made the application. So we're actually going to get into programming plugins for Imogen in native assembly. I want to also mention that if you're following this tutorial series and you don't want to use Imogen, you don't want to download it, I'll put a link in the downloads in the video description. But if you don't want to use Imogen and you're not interested in image processing, all of the information that we're going to go through is completely applicable to any other field as well. All we're really doing here is manipulating arrays of floating point values, and that's useful no matter what field of programming you're in. So even though I'll be explaining this stuff from an image processing background, you're free to use the information to do whatever you want. And I hope I still give out generic enough information that it's useful. Anyway, there's no installer at the moment. It's only Imogen 0.7, so it's not actually the final first release, but I thought it'd be best just to get stuck into AVX programming anyway. So the version on the website, it's got no installer, it's just got a little EULA here to read. Should give that a read if you want. It's also got a little manual. Yeah, but both of those are tentative, and the program itself is tentative, so it's going to change in the near future. Just download it. It'll be a zip file. Unzip it to your desktop or wherever you want, and double click on the exe. And you'll get something like this. This is the program. So it's really basic. My idea was that the front end itself, Imogen itself, can do absolutely nothing. All it does is loads and saves images and queries the plugins folder, which is right here. So when you first run the application, it'll make this plugins folder. And these DLLs just here is what we're going to be programming. Yeah, plugins is DLLs. And this will give the application all of its functionality. So at the moment it's got none, except for this one plugin that I've written here, which we'll go through in future tutes. And as a sort of bonus to speaking about AVX and SSE and native assembly, what we're also going to go through is how to communicate between native code and .NET 4.5, since this front end just here is C#.NET 4.5. Alrighty, so the program, like I said, is really simple. We just got a basic file menu. We got open files. So let's open up a file. Let's get one of these big Mars pictures. Look at that. There we go. Big picture of the surface of Mars. Would you believe it? Absolutely amazing. From NASA, I think. Yeah, incredible. Anyway, so if we just go through the program little bit by little bit, we got view at the moment only has image information. So if we click on that, we see that this is actually a gigantic image. It's a JPEG, 7,000 by 3,000 pixels. So it's huge, really, much bigger than almost every other photo I've ever seen. But in memory, as 128 bits per pixel, this photo here is actually taking up 346 megabytes of RAM. So remember that each pixel is stored as red, green, blue, alpha, and every single one of those components is a floating point value. The whole image is nothing but a great big array. So if you ever tried to deal with that sort of amount of data in C#, you'd probably find that it's completely hopeless. Which is where assembly comes in, really, or the SIMD instruction sets. To deal with 346 megabytes of floating point values in real time, you need assembly. Or the graphics card. Yeah, we might talk about the graphics card as well. Like, the graphics card is extraordinarily good at doing this sort of stuff as well. So hopefully in the CUDA shoots we can talk about some of this as well. Anyway, the plugins is really what we're here for. So this is what we're going to end up programming, is more plugins. And when the program first runs, it just looks in this directory, this plugins directory over here, and it asks each of the DLLs to identify themselves and say a little bit about the functions that they offer. And if they answer all of Imogen's questions properly, it'll make them available from this menu. At the moment, version 0.7 of Imogen only has one type of plugin, and it's a plugin that works on the entire layer, one single layer of an image. So there's actually only one layer available at the moment, and later on we'll add paintbrush plugins that track where the mouse is, and a bunch of different sorts of plugins. But at the moment, we're just dealing with one layer. So the negative plugin, these are all of these three functions come from that one DLL in the plugins directory. That's negative.dll. And all they do is turn the image negative. There we go. So you can double click on them, or you can click run plugin down here. Up in the corner you might see the time in milliseconds. That's a record of how quickly the plugin ran. So the plugin function for C++, that's the first one. That seems to be taking a pretty steady sort of 90, maybe 95 milliseconds or so to run. It's pretty quick. The SSE version, if we double click on that, we see that it's substantially quicker. It's taken maybe about 65 milliseconds. And the AVX version, so we'll go through the code to each of these in following shoots. The AVX version, you should see, is about the same speed as the SSE version. Yeah, so AVX is actually substantially faster than SSE. The reason why we're getting the same times here is actually that the bottleneck is memory reading and writing. Yeah, as our algorithms get more complicated and we look at things like convolution matrices or blurring and different things like that require a little bit more calculation than this particular algorithm, we'll see that AVX is substantially quicker than SSE. And we'll also see the gap between C++ and SSE and AVX increase as well. So C++ is actually really quick at the moment, 96 milliseconds compared to say 73 milliseconds. There's not much between them. Anyway, that's just a little introduction to the new app that I've made, and hopefully developers will jump on board and start making plugins for it. Yeah, if you want to send a plugin to me, I'd really like that. If you've made an interesting plugin for Imogen, just send me an email with the zipped DLL plugin and the source code if you want. But all of the intellectual property will remain yours. And hopefully I can start building a library of really useful plugins, and hopefully together we can make, an image processing application that works with 128 bits per pixel, and it works faster than 32 bits per pixel applications that everybody currently uses. If you compare the two, 128 bits per pixel wins hands down in quality of image processing. The only thing is you've got to be clever enough to program it. It's a little tricky, but we're assembly programmers, so we can do it. Anyway, thanks for listening. See ya.